Section 4.1, polynomial functions. And polynomial functions has a lot of terms. First of all, a polynomial function is in the form of f of x equals this. It looks really confusing, but there are specific parts of this. Notice that your x terms go down as your degrees decrease. You have a leading coefficient, which is your a sub n. You have your degree, often leading degree. That's the highest number degree there. And you have a constant term, which is your last term, and that's going to be a number. If it ends in x, then your constant term is going to be 0. Also notice that degrees have to be whole numbers, and the coefficients have to be real numbers. And that's going to get into looking like this. So these are all common polynomials. Notice you have a constant, linear, quadratic, cubic, and quartic. You need to know the names of those. Decide whether each are polynomial functions. So are all the coefficients real numbers? Yes. Are the degrees whole numbers? Yes. So this is going to be yes. And if I think about the degree is going to be 3. The type is going to be a cubic, and the leading coefficient is going to be -2. This, although you have a square root of 2, it is a real number. So this is a polynomial. This was a polynomial. This is a polynomial. And that, again, the leading degree is going to be 4. That's the degree. So that's a quartic. Quartic. And therefore the type is going to be quartic. The leading coefficient is equal to a square root of 2. This is not a polynomial because of that -1. They have to be whole numbers, which means 0, 1, 2, 3, 4, etc. This would be a quadratic because it has a degree of 2, leading coefficient of 1. Now, there's end behavior of these certain graphs, and the concept of positive infinity and negative infinity come up. That means it goes to a very high number without bound. Infinity and negative infinity are not numbers, they're concepts. So we have to keep that in mind. Now, when you see an arrow like this, that means it's going to a positive infinity because it's going, as it continues, your y's keep continuing to a positive infinity. Again, concept, not number. So you have to know the direction of the odd exponents, your odd degrees. Notice an odd degrees, it's either going to be going falling to the left and rising to the right, or vice versa. An odd degree is kind of like y equals x, because that's the first degree. And remember, that's the same idea here, falling to the left, rising to the right, as like this one, except you could also have a cubic or to the 5th power. By the way, it looks like this when your leading coefficient is positive. It looks like this when the leading coefficient is negative. You can also have even degrees. If you remember, y equals x squared. Y equals x squared looks like this. And so these graphs, to an even exponent, like to the 4th, the 6th, they are also going to look like this. Left and right behavior is the same, either both rising or both falling. So if your leading coefficient is positive, they both go up. If the leading coefficient is negative, they both go down. So this is something good to know as we go through. Now, as we go down, going to see if we have problems here, what is the end behavior of the graph? So this is, you're keying in on this term and on this term. So I know it's to the 4th power, so that means that it's going to be rising both to the right and to the left. But it's a negative, so that means we have to reflect it down. So in other words, it's going to look like this. We don't really know what's going on in here, but I know the left side and the right side are both going to be going down. Now, be careful how you write the end behavior, and this is going to be new. I want you to have the writing correct. It's going to be LIM, that stands for limit. As x goes to negative infinity, it's like a subscript of f of x is equal to, so as x goes to negative infinity, that means it's going this way. What's happening to your f of x? It's going to be going down, so that's going to equal negative infinity. This is known as left end behavior. What's happening on the right side as x goes to infinity? Well, it's the same idea. As x goes to positive infinity, your f of x is going to go to a negative infinity. It's going to go down, and that's known as the right end behavior. Okay, another type of question that can be asked is what do you get when you evaluate at x equals 4? It's the same idea as substituting a number in for x. So f of 4 is equal to a negative 4 cubed plus 3, 4 squared plus 9, and you would evaluate and get your answer. Same thing with negative 2, but you want to be careful with the negatives because it's very easy to get this wrong because of negatives, and I would suggest use parentheses. Oh, I'm not exactly sure how to spell that. That's embarrassing. I think that's right, but parentheses, I usually just say it instead of spelling it. Too bad there's not a spell check around here. Also, end behavior of this one, focusing on positive, and it's a cubic. Positive cubic means that it's going to look like this. Again, your only focus is going to be what is happening here and what is happening here. You don't need a perfect graph. In that case, you're going to have, again, the limit as x goes to negative infinity of f of x, writing it just like that, and limiting it, but I'm sure a lot clearer, limit as x goes to a positive infinity of f of x. This, as we go to the left, as x becomes negative, it is going to go to a negative infinity, and on this side, we know it's going to be going to a positive infinity. So end behavior, basic definition of a polygon.